We're going to do B in problem 5-43. Graphing the rules for part A is challenging because of the large numbers involved. Using a table could take a long time. Therefore, this problem is a good one to solve algebraically, the way you solved the problem in 5-42. Use the rules together to write an equation that represents when these high schools will have the same population. Then solve your equation to find out when the school's populations will be the same. What will the population be at that time? Okay, so we can do B and C pretty closely together. So we want to write an equation that represents when the two high schools will have the same population. So we can do that just by recognizing that Y is equal to the total population. So when both of these have the same Y, they'll have the same population. And because this Y is equal to all of this, and this Y is equal to all of this, if we make these equal to each other, then these two things are also equal to each other. And that's how we're going to set up our equation. We're going to set it up so 22x plus 1,160 is equal to negative 15x plus 1,900. So at this time, the population is equal to this population. So now, because we only have one variable, x, we can solve for x. And once we find x, we will know how many years it will take before they have the same population. So let's go ahead and solve. First, I want to get x on the same side. So I think I'm going to add 15x to zero out this part and add 15x here because we have to do it to both sides. And here it's 37x. And then we'll just drop down the 1,160. And that's equal to, well, this is zeroed out, so we just have the 1,900. So I'll write that down here. All right, now we're trying to isolate x, and so the best thing to do now is to zero out this, and I'll do that by subtracting that amount from both sides. Okay, so this zeroes out, and 37x is all that's on this side. And on this side, we're going to subtract, so that's 40. And 18 minus 11 is 7. Okay, so and then we've got a 0 there. So 740 is the difference between these two. And now we need to eliminate the coefficient x. And we can do that because 37 is multiplying x right now. We will divide by 37 to undo that relationship. And of course, we have to do it on both sides. So 37 over 37 is 1. 1 times x is just x. And then over here, 37 goes into 740 20 times. So x is equal to 20. And this is 20 years. So in 20 years, the population is the same. All right, but what we want to do is find what the population is going to be in 20 years. And so the way we'll do that is to take x, this value for x, and plug it back into one of our original equations up here, and that should tell us what the population will be. So I'll just write down post-falls equation right now, 22x plus 1160. Okay, and then I'll replace the value of x with 20. So x is 20. And now we'll multiply 22 times 20, and we will get 440 plus 1,160. So y is equal to, let's see, 40 and 60 will be 100, and that will be 200 plus 400, 600, and then we've still got that 1,000. Okay, so that is what the population will be in 20 years. So in 20 years, the populations, because it's both schools, will be 1,600 students. Okay, and we can check that by taking both of these numbers and plugging them into the other equation. So the other equation is y equals negative 15x plus 1,900. And so if we make 1,001 or y 1,600, and then negative 15 times 20 plus 1,900. So negative 15 times 20, so twice that is 30. And this is going to be a negative number. So that's negative 300 plus 1,900. And this is still 1,600 on this side. If we add these two together, we get 1,600. And that's what we have over here. So they are equal. And so we've just checked that these numbers, 20 years and 1,600 students, is correct.